Assalamualaikum and good day to all of you. So we will proceed with our lecture on how to look at the problems and to solve the problems pertaining to static equilibrium. So first thing first, you need to draw a diagram of the system. If given a question, sometimes they will give you a diagram and sometimes they will not. So you need to draw a diagram of the system. And then you need to draw a free body diagram of the system showing all the external forces related or acting on the object. Okay, so the FBD is very important in this topic. And then for systems containing more than one object, all right, you draw a separate free body diagram for each object. And then you choose a convenient rotational axis. Okay, so establish convenient coordinate axis for each object. You need to apply the first condition of equilibrium. So you know the first condition is something to do with the forces. So the total of the forces will be equal to 0. And for calculating the net torque, okay, on the object, you apply the second condition of the equilibrium. So the torque about any point will be equal to 0. And you can solve the resulting simultaneous equations for all of the unknowns. So you can reduce the number of unknowns in the resulting equation by choosing the axis. So that one of the unknown forces passes through the axis. This force will have 0 lever arm and produce 0 torque. So it won't appear in the equation. If the object is in equilibrium, it does not matter where you put the axis. Okay, remember that. And of rotation for calculating the net torque. The location of the axis of rotation is completely arbitrary. Usually, the nature of the problem will suggest a convenient location of the axis. Okay. And then when solving a problem, you must specify or be specific about the axis of rotation. Once you have chosen an axis, then you can maintain that choice. Okay, it's a must for you to maintain that choice consistently throughout the problem. Let us look at example 1, the swinging door. This is a very basic example for this topic, and if they ask you find the torque produced by 300 Newton, force applied at an angle of 60 degree to the door as shown in the figure. So this is the force, 300 Newton. Okay, what you should do in order for you to solve this problem, like I said earlier, you can actually use the first condition. Okay. Sum of all forces will be equal to 0, whether is it at x component or y component. So you look at the diagram carefully. So you determine the x component first. Okay, either one. Y component also can, and then x component also, you can do it. And then when you look at the diagram, you can see 300 Newton here. Okay, and then there's a angle there, 60 degree. So for the x component, this part, okay, you will get 300 Newton cos 60 degree, and you will get 150 Newton. So this one. And then for the y component, this one, okay, y component, so you will get 300 Newton times sine 60. Okay, sine 60, and you will get around this 259.8 Newton. Okay, and you can see that, okay, the 150 Newton force produces 0 since this is at X direction, you see, and the lever arm is 0. So when you apply the formula of torque, okay, you will get the value 0. So the 259 here, 0.8, around 260 here, has a lever arm of 2 meter. So this 2 meter, right? This one also. So, and it will produce a value of 519.6 Newton meter, right? So the plus sign indicates the door rotates in the counterclockwise direction, so CCW. Okay, so we move on to example 2. A uniform 500 Newton board of length L has two-way hanging from it, 600 Newton at L over 3 from one end and 700 Newton at 3 over 4L from the other end. What single additional force P acting on the board will produce equilibrium? So you need to find this P. Right, so the same thing, okay, you use the first condition of equilibrium. So sigma Fy equals to 0, because all this component, the forces is at Y direction. So you need to be consistent about the symbols. The direction, when you go upward, it is positive. So the P here is positive. Okay. And then minus this one, 600 Newton. And then minus 500 Newton. And minus 700 Newton. Since it go downward, equals to 0. So you will get P equals to 1800 Newton. And then, because the board is to be in equilibrium, we are free to choose the axis anywhere. If we choose it at end A, then by applying the second condition of equilibrium, which is sigma torque equals to 0. So you will get to actually solve the problem by using the formula of torque, which is force times the R, or in this case P is the force here, okay, and times the distance x here, right? And then minus 700 Newton, and you know from the diagram it's 3 over 4L, and then minus 500 Newton, okay, times half L, since the distance is half L, and then 600 Newton is L over 3 equals to 0. So you substitute the P, okay, and you will get P equals to 1800 when you solve this problem first, okay. To get X equals to 0.54 L, okay. So from the first condition, we get the P equals to 1800 Newton, and then you substitute the P with 1800 Newton, okay, you will get the X 0.54 L, okay. So the required force is 1800 Newton upward at 0.54 L from the left end. Okay, so we move on to center of gravity. Okay, so the force of gravity acting on an object must be considered. Okay, in finding the torque produced by the force of gravity, all of the weight of the object can be considered to be concentrated at one point. We call it as, we make it short, CG. So the CG is the balance point. An object suspended from its center of gravity, the CG, is in equilibrium in any orientation and will stay in that position. Alright, so let us look at example 3. So the location of a person's center of gravity. Alright, so when you look at the diagram there, okay, you see a man is lying down there, and a person has a height of L, and the value is 173 cm and weight of 715 Newton. Determine the position of his center of gravity by having him stretch out on a uniform board supported at one end by a scale as shown in the figure. If the board's weight WB is 49 Newton and the scale reading F is 350 Newton, you need to find the distance of the person's center of gravity from the left end of the board. Left end, which is at this part, this side. Alright, so the center of gravity must lie somewhere on the long symmetry axis of the body. Okay, so this is the XCG, center of gravity. To find the position of the XCG, set the sum of the torques about point O here, okay, equal to 0. So sigma torque, okay, equals to 0 at about point O lah here. Alright, so you apply the equation, the formula. Okay, so FL, okay, this one F, and the distance is L. Okay, so because the direction is upward, so we take it as positive, and then we minus with W here, and the distance is this XCG, and then minus with this part WB, and the distance is half of the L, and will be equals to 0. So now it's about rearranging the equation. So XCG is FL minus WB times L over 2, okay, and then divide by W, so will be equals to 350 here times 173 minus 49 times 86.5, divide by 715, so you will get 79 cm. Thus, the XCG measured from the head is about 46% of the person's height, which is 79 cm that we get, divided by the 173 cm times 100. So that's where you get the 46% of the person's height. And we look at example 4, the balance point. Okay, Ali and Ahmad have a mass of 40 kg and 45 kg respectively. Okay, each of them. Let's say Ali is 40 kg, Ahmad is 45 kg. They went to a playground and wanted to play on a centrally pivoted seesaw. Ali sat on the left of the seesaw at 2.0 meter from the pivot. So if the 4.4 meter long board must be balanced horizontally, where must Ahmad sit? Okay, so you must read the question carefully and you will be able to answer the question. So taking into consideration counterclockwise is positive, and then you can solve this. Okay, alright, so to balance the long board, the total torque about the pivot must equals to 0. So this one is actually sigma torque about P equals to, okay, P referring to the pivot, and then 40 kg times 9.81 meter per second, okay, times 2.0 meter, this one, okay, minus 45 kg times 9.81 meter per second, and then you time x, you'll get 0. Okay, so that makes x actually equals to 784.8 divide by 441.45, and you will get 1.78 meter. Therefore, Ahmad must sit at 1.78 meter from the pivot to ensure that the seesaw will be balanced. Okay, so that's it for this lecture. I will continue our lecture in the next session. Thank you very much.